All right. Hello, class. Today's video lecture is on simple machines. And this lecture is intended only for the 8th grade honors classes. So if you are not in one of the honors classes, you do not need to watch this video. You're more than welcome to watch this video, but you are not required to, and you will not get any credit for it. So if you are in the honors class, you are in the right place. Have your notes out and ready to fill out. So when we talk about simple machines, basically a simple machine is a simple device that has few or no moving parts. And by the way, I know your notes are fairly blank, so basically, any of these things that have a bullet point are what you need to be copying down into your notes if you want to get credit for this. So it's a device that has few or no moving parts, and the entire reason for simple machines and the reason that we use them is that it makes work easier. It allows us to do work with less force. But something that you have to remember when you talk about simple machines is that while it does make work easier, it does not reduce the total amount of work done. So if you remember our equation for calculating work equals force times distance, if you reduce the amount of force you are using, the trade-off is that you're going to have to move the object a further distance. But even with the extra distance, the work is still easier. So there are 6 types of simple machines that we are going to talk about and that we are going to be studying in depth today and over the next few days. And those types are the lever, the inclined plane, the pulley, the wheel and axle, the screw, and the wedge. And over the next few days, we're also going to be discussing a little bit about compound machines. And a compound machine is what you get when you combine 2 or more simple machines and have them working together. So let's talk about simple machines. This is how it works. This is how it makes work easier. So if you stop and think about it, there's almost always a way to make work a little bit easier for us. So if we look at this example, we have Joe here waving at us, and here's Joe's TV. So Joe wants to move his dresser from the floor up onto the top of his dresser. So if he just lifts the TV up, he has to move that TV 1.5 meters straight up, and he has to use 300 newtons of force to lift that television. So 300 newtons of force straight up a distance of 1.5 meters. So if we plug those numbers into our work formula, work equals force times distance, our Joe's work was 300 newtons, and the distance he moved the TV was straight up 1.5 meters, and that means that Joe did a total of 450 joules. So that's what Joe accomplished. He accomplished 450 joules of work, and he probably accomplished giving himself a really, really, really sore back. So, if he had been kind of a little bit smarter about it, maybe, he might have thought to use a simple machine. And one of the simple machines that he could have used to move his television here would have been a ramp. Now, if he'd used a ramp, his distance would be further, because if the dresser is 1.5 meters straight up, by using a ramp that is placed diagonally, he would actually have to move that television 3 meters, because some of his distance is going to be sideways. It's not all going to be straight up. So he has to move the television 3 meters with the ramp. And that's twice as far, but if he's using a ramp, he only has to use 150 newtons of force. That's half the force. So twice the distance, but half the force. And if we go ahead and plug those numbers into our formula, we see that 150 newtons of force times the 3 meters gives us the same 450 joules of work done. So if we compare the two methods, picking the television straight up or using a ramp, if he picks the television up, his distance is short. It's only 1.5 meters. If he uses the ramp, his distance is 3 meters, which is longer. If he picks the television up, his force used is 300 newtons, which is really heavy. And using the ramp, his force is only 150 newtons, which is not so bad. But the work done in either case is the same, 450 joules. So a ramp is a type of simple machine. And like I said earlier, a simple machine is a device that makes work feel easier by reducing the amount of force needed to move an object. And this part in red here is what I want to make sure you get in your notes. Okay? So you do have to increase the distance that you move the object. But most people would make that trade-off in order to make things feel lighter. So what I want you to have in your notes is that simple machines reduce the amount of force, but you do have to increase your distance. So if we look at our first type of simple machine, it is the lever. And everyone is probably familiar with levers. It's a rigid bar that is free to pivot on a fixed point. The fixed point that the lever pivots on is called the fulcrum. And that can be placed in different parts of the lever, and we'll be talking about that more when we get into our different types of levers. The second part of a lever that you need to be familiar with is the load. And the load, when we're talking about levers, is the object being lifted. And the effort, the third part of the lever, is the force applied to make the object move. So here we've got our little minion, and if we look at a very simple example of a lever, it's kind of like a seesaw here. And our fulcrum is right here. Our effort, or excuse me, the load is going to be our minion. Our minion is the object that we are going to lift. And the effort for this particular type of lever is at the opposite end. It's on the other side of the fulcrum. And the effort is going down, and the load, the little minion, is going to go up. So there are three different types of levers or classes of levers. The first one is the first class lever, where the fulcrum is located between the effort and the load, and that was the type of lever we saw in our example with the minion on the seesaw. A second class lever, the load is located between the fulcrum and the effort. And in a third class lever, the effort is located between the fulcrum and the load. So if we look at our examples with a seesaw, again, we have the fulcrum in the middle. Our load would be on one side and the effort would be on the other. An example of a second class lever would be a wheelbarrow. And in this case, your load goes into the bucket of the wheelbarrow here in the middle, and your fulcrum would be the wheel here, and the effort would be over here on this end. So that is a second class lever. Some other examples of a second class lever, and I want you to put at least one of the examples that I am talking about into your notes. So another example of a second class lever might be a bottle opener. And if we are talking about a third class lever, we can look at a shovel. Now here, the effort is going to be somewhere in here on the handle, because you are the one providing the effort, and when you're using a shovel, you generally grip it somewhere in here along the handle. The fulcrum is this end of the shovel, the tip of the handle, and the load would be the bowl of the shovel where you pick up the dirt. Another example of a third class lever would be a hammer, where you're holding the handle kind of not necessarily in the middle, but you're holding onto the handle, and the fulcrum is at the very end of the handle, and the work is being done at the head of the hammer. So again, in your notes, please make sure that you are putting down the examples that I'm saying and not just the examples that are in the PowerPoint, okay? That way I know you actually watched the video. All right, so the next type of simple machine that we are going to look at is the wheel and axle. So when you have a wheel and axle, you have two circular objects that are fastened together and rotate around a common axis. So some examples of a wheel and axle would be on the wagon here. Here's your wheel. Here's your axle. And here's your wheel, here's your axle. And in the back you have the same thing, wheel, axle, wheel, axle. And in this case, the work being done, the load is here in the bucket of the wagon where R2-D2 is taking a ride. Another example of a wheel and axle would be on a bicycle, or even in a car. The tires, the wheels of a car are attached to an axle if you were to look underneath the car. Some other examples of wheel and axle might be a skateboard or roller skates. The next simple machine that we are going to look at is the pulley. And a pulley consists of a grooved wheel with some kind of rope, chain, or cable wrapped around it. And what pulleys do is they end up changing the direction of the force. And they might change the direction once or twice or even more times. The more times the direction of the force is changed, the less force you have to apply, but the further the distance you have to move the object. So some common examples of pulleys would be a flagpole, elevators. If you were to look into the workings of an elevator, they work using a pulley system. Construction cranes are also types of pulleys. Another example of a type of pulley, and remember, I want you writing the examples that I'm saying as well. Another example of a pulley system, if you look at the blinds on windows and the way that you can pull them up, if you look at the top, you will see a little pulley. So window blinds would be another good example. So some types of pulleys are fixed pulleys. Fixed pulleys are attached to a structure. Fixed pulleys don't move, and those require greater effort than the load. And an example of a fixed pulley would be a flagpole. And then sometimes you have a movable pulley. And in the case of a movable pulley, the pulley is actually attached to the load. It's attached to the object that you want to move. And movable pulleys require less effort to move a load. So an example of a movable pulley would be in the elevator, where the pulley is attached to the elevator car. Another example is a compound pulley. And a compound pulley is a compound machine that uses a fixed and a movable pulley. So it combines the two types of pulleys. And when you use a compound pulley, you are cutting the effort in half, even more than in half. So the amount of effort is less than half of the load. And compound pulleys are the types of pulleys that are used on construction cranes. In our example of window blinds use a fixed pulley system. The pulley doesn't move. So the last three simple machines that we are going to discuss are actually related to each other. So the next one we're discussing is an inclined plane, and sometimes people will call an inclined plane a ramp. An inclined plane is a flat, slanted surface. And inclined planes work by reducing the force needed to move an object by increasing the distance. And remember, in our example at the beginning of the video where we had Joe and his TV, he doubled the distance moved, but he cut his force in half. So when you have a heavy object that you want to lift, you don't want to just lift it up by hand. That's a lot of work. That's a lot. Well, it's the same amount of work, but it it requires a lot of force to just lift a heavy object straight up. But when you are using a ramp, you get the exact same amount of work done, but you can use a lot less force. So the next simple machine is the wedge. And like I said, these last three are all kind of related to each other. So a wedge is a device that is thick at one end and tapers to a thin edge at the other end. And actually, wedges are composed of either one inclined plane or two inclined planes back to back. So if we look at our examples, if you were to ever look at the edge of an axe, you would see that it's got a very fine edge that tapers out and gets wider and wider on both sides, and it's actually two inclined planes back to back. Doorstop, just like the wedge that I use in the classroom, is an inclined plane. Here you'll see that the bottom is flat and the top is just an inclined plane. Another example would be the end of a shovel. If you look at the end of a shovel, the edge of it is sharp, but the shovel kind of gets a little bit wider as you go further into the bowl. Some other examples of wedges would be scissors, even push pins like you put into a bulletin board. If you look at them, the tip of the push pin is extremely sharp and extremely small, and it gets wider and wider as it goes further up the metal pin, and that's actually a type of wedge. Remember, put down some of the examples that I'm saying, not just the ones on the PowerPoint. So the last type of simple machine that we are looking at is a screw. And if you look carefully at a screw, it's just an inclined plane, but in this case it's wrapped around a cylinder. So if you look at a drill bit, you'll see here we have the inclined plane and it goes around and around the cylinder. So it's just an inclined plane wrapped around a cylinder. Jar lids that screw on. If you look very carefully at the threads, it's just an inclined plane around a cylinder. And a corkscrew is also a type of screw. And just the regular household screws that you use to hold things up on your wall, those are examples of screws. All right, so that is all that I've got to say about simple machines. So get your notes filled out and get them turned in, and I will see you in class. All right, bye guys.